honorable experts, and other participants. I'm Xinde from School of Automation, Southeast University and Nanjing Center for Applied Mathematics. Today I would like to present the topic about robot occasion cognition in coexisting-cooperative-cognitive, TRICO, human-robot interaction. According to the research background and challenges, the representation mainly introduces our scheme, recent researches, conclusion and prospect. The first is the research background and challenges. A good, harmonious and natural human-robot interaction environment puts forward very high requirements for humanoid performance of robots. Just as service personnel need to perform services according to different occasions, including various people and local conditions, robots also need to have such cognitive ability to perform services more naturally and accurately. For example, for the service request, go to the office and get a banana for May. The robot not only needs to understand the place and the object in the occasion, but also needs to pay attention to the emotion, mood and other psychological conditions of the target person in the occasion. Therefore, accurate occasion cognition can well promote the integration of robot interactive services. In the 1970s, the concept of context-dependent memory was proposed, and subsequently, the mechanism of context-dependent effect was mainly revealed from the perspective of psychology. So, what is the concept of occasion? Occasion is the set of things that are happening and the conditions that exist at a particular time and place. Different from place and scenario. Place is a position where in relation to other things or people, generally referring to a specific region. For example, the way of shaking hands in the picture above, not only the place of shaking hands should be considered, but also the time, the identity, emotion and other comprehensive occasion factors should be further considered. Therefore, in order to empower robots to understand occasion according to various people and local conditions, natural person/place cognition is the key technology to promote robot occasion cognition. However, there are 4 challenges in adapting robots to different occasions. First, the natural person emotion characteristics present a strong subjectivity, resulting in the low accuracy of emotion understanding. Emotion characteristics with strong subjectivity cause great obstacles for robots to understand the real emotions of natural person. Secondly, the place location of service occasion is highly complicated. The functional room is no longer constrained by the physical partition, but presents a certain openness and clutter. The information of the place environment is bound to be highly complicated, which brings challenges for robots to understand such unstructured place environment. Then, in the aspect of information representation, the existing methods have low ability to represent the multi-heterogeneous place information, resulting in poor discriminability. In the multimodal environment, there is no unified and effective theory to guide the abstraction of clues. Depicting what kinds of clues and how to represent the clues are the key points to solve the problem of place perception in the occasion. Finally, black box inference mode of deep learning has the problem of poor interpretation. The black box mode lacks the interpretability of inference process and results. The key to reveal the semantic mechanism of robot understanding is to construct a clear and interpretable inference method. Based on the above 4 challenges, we take human-robot integration as the starting point. The scheme of our researches is as follows. In the background of human-robot integration, we divide the problem into 3 levels. We hope that human beings and robots can show a form of behavioral integration in the same occasion in a harmonious way. However, through further analysis, we argue that in order to achieve behavioral integration, first of all, it is necessary to enable robots to achieve information integration and thinking integration, so that they can truly make no difference from human beings. Therefore, we hope that the robot can have similar information processing methods and cognitive mode of thinking with human beings on the occasion cognition problem, which makes the occasion understanding process more interpretable. That would enhance the ability of robot for planning and execution towards the different occasions. Therefore, through the above analysis, we propose a framework for robot occasion cognition based on semantic clues, multimodal information fusion and knowledge graph reasoning. Under this insight, we provide the specific research schemes from different aspects. We provide the specific research schemes and methods according to different levels of the framework for robotic Asian cognition. Based on the above research schemes, I will introduce the main researches of our team in the recent years. Our main researches can be summarized into 4 parts, namely gait identification and emotion recognition, place perception based on text semantic clues, place perception based on multimodal fusion, and place understanding based on knowledge graph reasoning. Next, I will introduce the details of each part. First, I will introduce gait identification and emotion recognition based on multitask learning. Gait conveys rich information, including not only identity information but also emotion information. Prior studies treat identification task and emotion recognition task as independent subproblems, ignoring the rich correlation information among problems. Thus, we introduced the multitask learning to utilize the mutual promotion among tasks. The model is trained to identify the individuals, enabling the model to obtain the ability of emotion recognition indirectly. We propose a deep learning network for gait identification and emotion recognition based on multitask learning architecture. We share information among multiple gait subtasks and learn a unified gait feature space. Under this unified architecture, we conduct joint learning of 3 gait tasks, including identification, emotion recognition, and gait prediction, which helps tasks with less data obtain more discriminative features from supervised learning of other tasks with richer data. We design a set of experiments based on the same multitask learning architecture, and compare the GCN model with other skeleton-based models. The comparative experimental results show that compared with the existing skeleton-based model, the proposed GCN model and the multitask learning method have achieved better performance in 3 tasks. Moreover, the ablation studies verify the mutual promotion between multiple tasks, to empower robots to adapt to the local conditions. How to accurately perceive the natural places is the key to this process. For the place representation, we explore text semantic clues, which is a place perception method based on the image paragraph description. First, we give a definition of place semantic clues, including the necessary semantic sets to describe the places. The sets consist of object set, attribute set, state set, and relation set. Under such a set definition, any place can be composed by the elements in these sets according to certain rules. Then, the various semantic clues can be generated via image paragraph captioning. Finally, LSTM and neural network are used to classify the vectorized semantic cues, realizing the text-based place perception. We utilize the dataset visual genome to conduct the experiments, where the partial of images are annotated with place categories. The left table is a statistic for the number of semantic descriptions. The right figures are 2 examples to visualize the descriptions. The experimental results show that even if there is only 1 semantic clue, it is possible to get the correct recognition results, which is consistent with the generalization ability of natural language. Moreover, when the descriptive semantic clues are sufficient and the information describing the place environment are diverse and accurate enough, the place category can be uniquely determined. These results verify the effectiveness of the place perception method based on paragraph description. After exploring the text-based description, we further study the place perception method based on multimodal fusion. With regard to multimodal fusion, on the basis of deep learning, we focus on the fusion method for feature vectors. There are 2 main aspects: when and how to fuse the multimodal features. The existing strategies include data-level fusion, decision-level fusion, and feature-level fusion, which lack the locality of feature fusion, the selectivity of feature representation, and the universality of fusion formulations. To address these issues, we propose a multi-head co-attention fusion based on transformer structure. Weighted selection fuses features between different modalities through co-attention represented by local global dependencies. We conduct the experiments on multimodal multi-label classification tasks, as can be seen from the results in the left table. the proposed fusion method is superior to the existing fusion strategy for both label settings. Then, according to the proposed multimodal co-attention fusion, we design a place perception method based on the fusion of heterogeneous image representation. Here, we rethink the discussion of the cognition procedure of human beings. It can be found that after human beings observe the place environment, the brain extracts, analyzes and abstracts the data through the senses, and eventually obtains some conceptual references. However, sometimes the objects of these semantic references often contain some subtle differences for human beings. For example, the conceptual semantic clues of pools in the two different images. We can clearly distinguish that the left pool comes from the bathroom, and the right pool comes from the kitchen, which is related to our cognitive experience and the specific differences of the observed objects. Therefore, in sense that, the low-level cognition reflects the difference between objects, while the high-level cognition reflects the similarity between them. For objects with the same semantic concept, if specific to the low-level information, it can also be used to distinguish the category of places. Based on the above analysis, we propose a new method to understand the place. We combine the two representations of image to simulate the cognition procedure of human beings. A place perception based on image and textual representations is proposed to jointly perceive the place. Besides the co-attention mechanism, we propose two different designs for the final fusion perception module. The first strategy is to fuse the image features and semantic features in the local region in terms of feature level. We evaluate three different fusion operators and utilize a better fusion method. This kind of fusion strategy is similar to people's interest in a region, and then, focus on the processing and thinking of this region when observing things. Through experiments, we compare the performances of the models with different fusion operators. The feature-level fusion using Hadamard product operation achieves the optimal result. The second strategy is to fuse all the regional features of the whole image from the perspective of object level or instance level. There is a key problem that how many local regions are fused? We determine this variable through two statistical experiments. Based on these two statistical results and multiple rounds of experiments, it can be concluded that 16 is the optimal number of descriptors for object-level fusion. In the ablation experiments, it can be seen that semantic features play a dominant role for the final results. Meanwhile, multimodal feature fusion effectively improves the accuracy of place perception compared with the single-modal. Finally, we compare with the state-of-the-art methods, and our method achieves the superior performance in terms of accuracy. At last, in order to provide the interpretability of reasoning results, we explore the place understanding method based on knowledge graph reasoning. The insight to introduce the knowledge graph to construct the place understanding framework is inspired by the cognition procedure of human beings. The construction and reasoning form of knowledge graph are very similar to the cognition procedure of human beings, which have the potential value for realizing place reasoning and understanding. Here, we introduce a novel triple knowledge structure of place, and propose a method to compute the probability relation between entities and places. The co-occurrence probability is used to replace the subordinate relation, presenting the probability of things appearing in a specific place. The uniqueness relation between entities and places can be avoided, resulting in enhancing the discriminability of places in semantic reasoning. Based on the above place knowledge construction, we propose a general framework. A reasoning framework is designed to extract effective semantic clues from multi-source information, and construct a knowledge graph according to the co-occurrence probability to realize the reasoning and understanding of the place. In the experiment, we validate the performance of place knowledge graph reasoning. Finally, we summarize the works of the team and make some prospects for the future progress of this topic. We summarize the natural person and place in the robot interaction environment as the occasion. The concept of robot occasion cognition is first proposed by our team. Meanwhile, we further study the topics on identification and emotion recognition, place perception and understanding. A new paradigm of robot occasion cognition is proposed towards various people and local conditions. At last, we have the following prospects for robot occasion cognition. From the point of theory, what is the general theoretical framework and system of robot occasion cognition? Although we have initially given a framework here, it is still incomplete. Meanwhile, the research scope and theoretical method of occasion cognition are studied to further reveal the humanoid mechanism of robot occasion cognition. From the point of discipline development, occasion cognition is an interdisciplinary subject in cognitive science, social science, artificial intelligence and other fields. It can establish an organic relation among various fields is a feasible idea for future research. Finally, from the perspective of application, the robot occasion cognition can be extended to more industrial applications, such as human-robot collaboration, robot services, virtual human services and so on. Okay, it is my overall presentation about robot occasion cognition in Coexisting-Cooperative-Cognitive, TRICO, human-robot interaction. Thank you very much for your kind attention.